re itse re na le EMF, which re bontshitse gore EMF is given as that. Then re itse re na le potential difference, which is given as that depending on what resistor you are working with. If you are working with the total potential difference, which means that you will be working with the total resistor. And there are two possible ways of measuring a total resistor. We can have resistors connected in series connection or a series circuit. Then we say that the total resistor in a series circuit, you just add the resistors that are there. Can be lots of them. And we can have resistors in a parallel connection, which is very, very important for you to know the difference between the two. So we can have this as parallel circuit. Then the total resistor can be measured from this equation. And all of this R total, they can help us to calculate the V total depending on what the question is asking. And obviously we can have, this is in the external circuit, external part of the battery. For the internal part of the battery, we can have current flowing through the battery and multiplying the internal resistor if we want to calculate that. EMF, as we saw, it can also be given as EMF is equals to V external plus V internal, which led to the birth of the equation that we managed to come up with. The total resistance in the external circuit multiplied by the internal resistance. So this is very important. And we talked about the power conversion in the EMF, and we saw that the EMF, the power conversion is from chemical energy to electrical energy. Because a battery, when you buy it, for example, we talked about a simple battery, which you call it a cell. When you buy and maybe you decide, let me break this battery, you will get powder. So you have that chemical potential energy. And once you plug it in and it's still very powerful, there will be some work done to convert that electrical potential energy for each and every charge so that current can be induced, right? So that's what we have. And we also talked about the potential difference, where we have the work done. Now that we have the electrical energy, we now have that electrical energy that is coming from the EMF. Will be converted to other forms of energy. And we don't specify them because it will now depend on the type of resistor that has experienced that current. If we have stove, that electrical energy will hit the stove and the stove will convert that to heat energy. That is an example that we gave. And if we have maybe a bulb, electrical energy to light energy and also heat energy, right? Not just light energy. When you heat fridge, electrical energy is converted to that cold energy or whatever mechanical energy that is causing the cold energy, and also mechanical energy and sound energy, because you can hear the sound of the fridge when there is electricity, right? It will just act up a bit and gives you that mechanical energy and some form of things moving in a fridge to make it cold, right? So that is a quick summary of what we were